back. This is video 2 in the video series for practical application number 9 in chapter 5 of the Advanced GIS textbook. In this video, we are going to be bringing in Landsat data and processing it for NDVI and surface temperatures, and then subsetting that data to the area near Springville, ultimately trying to compare values from 2010 and more recently 2025 over 15 years of change in urbanization related to green space and parks in the city. And so how do we get surface temperature? How do we get NDVI? You can look this stuff up. Surface temperature values, and generally the values coming in Landsat data, which I've got loaded into the project over here, you'll see have these what are called digital numbers. I believe they're 16-bit digital numbers, integers, and that does not look like a degrees of Kelvin or Celsius or Fahrenheit. And also in these other bands, so band 6 for 2010's Landsat 5 is thermal infrared. These other bands are reflectance in visible and near infrared, same sort of thing, right? So we need some way to convert these out of digital numbers in some cases. In the case of NDVI, it's not really required because the same scaling factor to go to, say, the units of watts per square meter, it's a ratio, so it's not gonna matter in the case of NDVI. But for degrees, we need to do something. And so the data that we've downloaded is called analysis ready data. And there's this formula, the digital number times this plus 149. If you look up converting temperatures, it's going to vary by band for the more recent Landsat data, and the metadata have information that'll help you do that conversion. But with this analysis ready data, it's a simpler process. So I have copied that formula. And so the digital number from band 6 is multiplied by that conversion factor plus 149 to get it into degrees Kelvin. So that will be July 2010 surface temperature K. Okay, and then I click run. And now, indeed, it does look like degrees Kelvin is what we have there. Okay. And so that's great. One thing that you might not be familiar with is thinking about degrees Kelvin. And so we could convert that to degrees Celsius. And Kelvin is absolute, takes into account absolute zero. And so it's just off by 273.15. So we can just say, turn it into surface temperature Celsius by minus 273.15. So that should work to get us into degrees Celsius. Oh, failed. Let me run that again just to be sure it's. I'm going to back out of this and back into it. And now I'll call it surface temperature 2010 C. How about that? Ah, there we go. So, yeah, so somewhere in there it's pretty cold, maybe up on the mountains, or maybe that's a cloud temperature. Um, if you look around and like start clicking on some of these high brightness areas, these high temperatures, we'll see that, oh my God, 49 degrees Celsius, that's hot. It's important to remember that these are surface temperatures, not air temperature. Think about the temperature of a pavement um, or rock baking in the sun on a July afternoon. That's going to be very different, right? As compared to like the top of the mountain, 11 degrees Celsius, that seems more reasonable. So yeah, these are surface temperatures, the ground surface, not the air temperature. Okay, so that's works. And so another thing that, and we'll come back to this later on, for since we are talking about surface temperatures and not air temperatures, and it's like, what do I want to think about how things have changed in the, or are relatively warm or less warm in the park areas or the green space areas, is I might actually want to convert this surface temperature to surface temperature deviation from the average or something like that. So we might do that later on. We could also convert this to uh, Fahrenheit if we wanted to, right? We could um, go in here, delete this, and change this to F. You want to think about that some more. So then we could take degrees Celsius times 9 divided by 5 plus 32. Is that right? I think that's right. So yeah, the conversion for yeah, Celsius times 9/5 plus 32. That's correct. Um, now we'll run that. Yeah, so things get to be pretty warm. Okay, so I'll hold these aside for the moment. Now I have a bunch of rasters in here that need to be clipped to the area of analysis, and I'm going to produce more. So um, we've got surface temperatures for 2010. I've already produced them for 2015, so I won't show you that. NDVI, the process of that is another raster calculator analysis, although there may be an NDVI tool in here. Let's see if that's true. Doesn't make sense necessarily. It's such easy math, right? So let's just go to Raster Calculator. So to do normalized difference vegetation index, it's the near infrared minus the red color bands, rather, divided by, so it's the difference divided by the sum of those two bands. And so in the case of the 2010 data, that's bands 4 plus minus 3 divided by 4 plus 3. So we can set that up really easily, right? You just parentheses and 4, oh, goodness, minus band 3, and then do a division symbol, parentheses, band 4, you have to double click these things, plus band 3, parentheses, and then this would be called NDVI 2010, and then just band 4, band 3, just to remind myself I did it right, I guess. But you don't need to do that. Yeah. And indeed, it's between 1 and -1 values. And we can see the areas that are closer to 1 are bright. Those are supposed to be green fields. We can see that there's some weird little bits of vegetation along these channelized zones in West Mountain, and that the mountains themselves have quite a bit of active vegetation in early July 2010, whereas the State Street does not. Okay, so great, we've got NDVI. We can display that in some different ways. It's just a simple stretch right now. And stretch is a good way. You could also classify it to vegetation, non-vegetation. Not going to worry about that right in this video. But, you know, a high value being kind of greenish and a low value being kind of brown would make sense. And then, so that kind of shows us veg, non-veg more intuitively. We could go to standard deviation to make it a little bit more practical. It's going to display for me. I'll go to. Okay. So it's 1 standard deviation. If I go to 2, it'll be a little bit more nuanced. Yeah. Okay, so there's my NDVI for 2010. Similarly, we could go back to surface temperature and turn these other ones off and go to the Fahrenheit one and think about warm to cool temperatures and see where surfaces are hot, not. And so we see that the lower altitudes are warmer, bare soils are hot, and maybe urban areas hot as well. Okay. Actually, one thing that can be seen from this surface temperature is that there's an asymmetry where we're seeing the east side of like West Mountain here hotter than the west side. So this can be found in the metadata, but we know that the Landsat image must have been taken in the morning when those surfaces were getting warmed up and the other side was cool. So keep that in mind. Yeah. So, you know, these surface temperatures can be even hotter at a different time of day, right? Okay, so yeah, we've got surface temperature kind of nicely colored, and we've got NDVI. Okay, so then how to subset these, and I'll subset the 2015 ones as well, but I won't show it in this video. So we can use what's called a raster clip, and we could batch process that. Let's demonstrate that. So I believe this is under data management tools, raster processing, Clip Raster. Now I clicked right on it. If you want to batch click, you right click it and say batch. And this will be a temporary batch tool, but you could make it something that you save, right? But I'm not going to do that here. And so then you just, the things that we want are the ones that I just produced that are kind of more finalized, the NDVI and the surface temperature. And the benefit of this, right, if you have a bunch of files, so I could do it on a lot of them, but there's some value to doing it just on 2. And the output extent is going to be to Springville City. And so Springville City, remember, is hiding. Where is it? Okay. So we'll bring that up to the top. That's our clipping area. And we want to cookie cutter these out. So you also need to click this Use Input Features for Clipping Geometry. And then we run it. And it's going to say clip out %name of the raster. So the input raster, we'll get that. Oh, that didn't quite work. I think it will. I'm going to change the name a little bit. It's too long. %name clip. How about that? It seems to be working now. Sometimes get errors working in the geodatabase with these file geodatabase feature rasters. They don't like to be so small, apparently, and sorry, long names. So keep that in mind. So there's our surface temperature for Springville, and then our NDVI for Springville. Now, if you want these to match the symbology that you just made, you can always import from a layer file, a layer that's already open, and then you just point at, I want it to be like, so this is surface temperature clip, I want it to be like surface temperature F. Let's do run. And then you get the same scaling. Yeah, there it is. Okay. Now there's still, you might, it'll be scaled like that, but you could customize it a little bit, right? And it depends on what you want. Anyways, so there's surface temperature over Springville. And then we can take the NDVI one, go to its symbology, and import from the similar layer. And I can turn these other ones off so we can see more clearly. With some display functionality issues going on, but there's my NDVI for Springville in 2010. Okay, so yeah, that's batch Clip Raster. And so yeah, we've got those things clipped to those areas. Note that there's some display functionality issues that I seem to be having going on. Like sometimes it wants to display it, sometimes it doesn't. Some things to solve that may be to generate pyramids for that file. So if you go to catalog and you can find it, I've got so many things open now. That one is called NDVI. This one, I can say build pyramids. That might make it stop kind of behaving a little buggy in the display functionality. And if you get the option, you can always say always build pyramids every time you produce it. That's helpful. And same thing for surface temperature, I could do that. Another thing to do would be to calculate the statistics for that as well. That'll help with looking at the histogram, creating kind of custom classifications of the raster, so on and so forth. Okay, so that was producing the NDVI, creating surface temperature map from digital numbers and clipping the rasters. So that's video 2. Video 3 is going to be using Model Builder a bit to take some, say we've produced a bunch of rasters and take them out of a geodatabase. So we'll demonstrate using Model Builder to create a custom tool that we might want to save for doing something we might do over and over again. And in that video, I'll talk to you about why you might want to have an easy way to export a bunch of rasters from a geodatabase. And yeah, so that'll be part 3 of this video series. This is the end of part 2.